Objective 5, in Part 1, Module 3. This is the fifth and final objective in Part 1. It's called Factoring a Difference of Squares. So by the end of this video, you should be able to recognize these special cases that exist and use the strategy I'm about to show you to factor them. Now, up until this video, we've been working with just previously what's called quadratic trinomials, meaning quadratic is the highest power of 2. And then there are 1, 2, 3 terms. So this is a quadratic trinomial because there's 3 terms. Before that, we worked through quadratic binomials, meaning that it's still quadratic. It will always be quadratic for now because it's the highest power of 2. But in this case, binomial because they are 2 terms. So binomial because there's 2 terms. So if you notice, we're still going to be working with quadratic binomials. But in this case, for quadratic trinomials, you use the MATLAB T-chart. For quadratic binomials, in the previous videos, you just factored by finding the GCF. In this case, it's going to be a little bit differently. And hopefully by the end of this video, there will be 2 key features that will jump out at you if you see one of these on a test where you can utilize this strategy we're about to talk through. Now, to begin though, we can go ahead and use the MATLAB T-chart that we did in the previous video to factor. So if I was going to do number 1, again I would notice that it's a quadratic binomial, but if I was going to use the MATLAB T-chart, the first step is always the same. Identify the A, the B, and the C. Now my A is still 1, so A would be 1. B, there is no B term. And then this is the C. Remember, the B term is always a number with the linear x, but there is no B term, so in this case the B is 0. And then C would be negative 25. So I can use the MATLAB T-chart, same as always. And my MAC term would be A times C, which is negative 25, and my B term is 0. So I need factors of negative 25 that add up to 0. And this will show you the process as to why this is called a difference of squares, and that's what I'm going to hopefully get you to be able to see so you can avoid using the MATLAB T-chart in the future when you practice these on your own. But for this case, I need factors of negative 25 that add up to 0. I can always start with 1 and its partner. Negative 25 divided by 1 is 25. Well, negative 25. But no combination of positive, negative 1, or 25 would give me 0, so that doesn't work. Next, after 1, the number is 2. 2 does not go into 25 evenly, so it is not a factor. Then let's try 3. 3 also does not go into 25 evenly, so it's not a factor. We try 4, same thing. 4 doesn't go into 25. If you want to test it, take your calculator and do 25 divided by 4. You will get a decimal, so it doesn't go in there evenly. And finally, 5. 5 looks promising. Negative 25 divided by 5 is a negative 5. And I have to make one of them negative because a 5 times a positive 5 would be a positive 25, and that doesn't satisfy this situation. But a 5 times a negative 5 does indeed equal negative 25. And then the other piece of this puzzle that we're trying to figure out is, do our 2 numbers add up to 0? And in this case, 5 plus a negative 5 does indeed equal 0. So these are my factors. So remember, that's the first step. This is the second step, the T-chart. And then finally, the third step is to write it in what's called factored form. Factored form. So for factored form, I would place a variable in each of the binomials, or each of the factors, and the variable of n. One gets a positive 5 right here, so plus 5. And the other one gets a negative 5 right there, so n minus 5. And I am done. So if you did it that way and used the T-chart to get to that final answer, that is perfectly fine. But I want you to be able to notice why these are called a difference of squares. Let's look at this binomial, n squared minus 25. Now if you think about numbers that are perfect squares, 4, 9, 16, 25, what that means is that there is a number that you can square to get to the final product of the perfect square that you're thinking of. And let me explain that a little bit more. Let's take the first term, n. If I take n squared and I take the square root of it, that would give me n. Another way to look at it is n squared equals n times n. Alright? That's why each factor always gets a variable, whatever variable is in question, when it's squared. Now let's look at the number 25. Hopefully you can recall some math knowledge that the square root of 25 equals 5. Or another way to look at it is 25 equals 5 times 5, or it equals 5 squared. Same thing. So each one would get a 5. But why does one have to be positive, one have to be negative? Well, we proved it in the MACAB T-chart because it has to add up to 0, so one has to be positive, one has to be negative. But we're going to talk about this later in this module. Whenever you take the square root of a number, so let's look back up to the square root of 25. Technically, when you're taking the square root of a number, the answer has to be the plus and minus version of that number. Because if you were to redo that math and test your, because this is plus or minus 2, and test your math, the positive version, 5 squared, does indeed equal 25. But also, if you remember, the negative version of that number, 5 squared, equals 25 as well. So you have to include the positive version and the negative version of the number if you're taking the square root of something. And that's why the positive version and the negative version show up in your factored form. So without even using the MACAB T-chart, hopefully as you practice these, you can just use the shortcut of taking a difference of squares and taking the square root of both. The square root of n squared and the square root of 25. Now that would tell me that each one, square root of n squared we said was n, so each factor gets an n, and then the square root of 25 is a positive and a negative 5. So it gets a positive 5 and a negative 5. So yours, and that's the same as what I got with my MACAB T-chart. So as you're going through and finishing out this practice problems of 2 through 10, you could take the square root of both terms, and hopefully what jumps out at you is that n squared is a perfect square, and 4 would be a perfect square. X squared is a perfect square, and 16 is a perfect square. So this strategy of taking the square root of both and jumping immediately to factored form only works with binomials that have a special case where they're both perfect squares. If you consider these binomials, because if you venture on a test and think, hey, this is a binomial, but neither of those are perfect squares, so you can't use that strategy. In this case, you would have to take the greatest common factor. But if you venture to one and see that it jumps out at you that these might be both perfect squares, then you can try to take the square root of both. And if you get even answers for both, then you can jump immediately to factored form, one with a positive version and a negative version. So I need to see, in this, I don't necessarily need to see the T-chart, but I need to see that your knowledge of taking the square root and getting to the positive and negative version of the answers in factored form would be sufficient for this.